Okay, so quickly just, hey, recording there. This guy here, I'm just going to go over like what is it that we have to solve for? I really find this question fascinating just because of the construct of it, and it tripped up a lot of people. Okay, this is talking about stocks. So on this guy here, you are buying like shares of stocks. The actual value of that stock somehow magically follows this parabolic trajectory right here. So this is a rule already given. And you need to identify, first off, when you look at that guy, what form is that guy in? What form is he in? General form. So the first thing we need to know is that this is in general form. And where should you be going next in like your thought process is that I'm going to look to the formula sheet and look at all of these things here. 4ac minus b squared over 4a. X's and zeros can be solved by using minus b plus or minus square root of b squared minus 4ac, all divided by 2a. Or I can just plug in an x and get a y, or vice versa, and all that kind of stuff. From these formulas, let's walk through what we're actually being asked. Do you make a profit or loss if the share is sold 2 weeks after reaching its maximum value? Everyone read this yesterday and saw the phrase maximum value and immediately tried to solve for K. The problem with that is that we don't need to know it. We didn't need to know what its max value was. We needed to know when it reached its max value. So the when would be the H. So this is basically when. Time is always going to be X, so H can always be when if you want to classify it like that. So that would be your first step, knowing that A is negative 0.1, B is 1, and C is 4.5. We could plug those things in and solve. So negative 1 over 2 times negative 0.1. And I think it was something along the neighborhood of 5. Do you make a profit or loss if it's sold 2 weeks after its max value? So now that I figured out when, we can basically just add 2 weeks to it. This is when it was sold. When it was sold. If I have to determine whether or not he made a profit or he made a loss, I'm going to have to figure out the value of that. So where does this come into play? You're going to have a good knowledge of that if my x-axis is time and my y-axis is value, and my objective is to determine profit or loss, I am going to be looking for a value given a specific time. And the specific time I'm looking for is going to be 7. Okay? So this is probably the hardest part to get your brain wrapped around. What is the y-axis? What is the x-axis? How do the two relate? What is it that I'm looking for? So you would literally just plug in y is equal to negative 0.17 squared plus 7 plus 4.5. And I think it was something like 6.6, right?
Yeah.
So last but not least, the other thing that people were looking at in terms of comparing was what was the profit or loss. The premise of this guy is relatively tough unless you remember that your y-intercept is the value C in general form. And if we think about it, that means y-intercept means time is 0. Time is 0 would correlate with when it was purchased. So that would mean for something like this here, time purchased, it was a y value of 4.5. And he sold it for 6.6. So that means he did, yes, make a profit. But again, what's the hard part about this guy here? A lot of people were able to find K really easy. Didn't matter. I'd give you no marks for that. A lot of people were able to start to plug in the quadratic equation. I knew that this is something. Some other people were trying to convert this guy here to another form, which the only conversion you'll ever have to do is zeros to any other form if they require you to find an actual x value. And that's it. Other than that, whatever form they give it to you in, you can use the form that you have. Any questions on that? Okay, I just wanted to kind of wrap that guy up in a bow because I found it like a really challenging one that kind of got you to flex your muscles. And we kind of finished off on this guy right here. And so I'll give you the context. We'll do these next couple. I'm just going to just sort of prep you and then leave you on your way to go ahead and solve for them. Position in meters, diver relative to the surface described by that following rule. First things first, you now know that this is in general form. You don't have to write out the formulas underneath. I just did that last time to show you that's where your eyes should go on your memory aid. Now, if that's the rule, and we're talking about like an actual like Olympic diver, okay, then what you would have, and what is important is that X is time, and Y is height. And if you have to sketch it out, right, you should know full well that he's starting at 10 meters high and then goes into the water like such. Okay? It's a positive A, so it's a smiling parabola. So if your objective on this guy is to determine how long he was underwater, what are you looking for? If not, the distance between those 2 points, and I'll leave it at that. Can you think right now, what is it you'd have to solve for, by the way? Huh? 0. So Z1, Z2, what's the distance between the two of them? Perfect. I'll leave you to do that one on your own. Let's prep this one here. The trajectory of a stone thrown from a seaside cliff is a partial parabola. So the position in meters of the stone relative to sea level is given. So there's a cliff. If you like to do drawings too, right? You've got your little cliff. We can call that the edge of the cliff is the y-axis, and we can also say that this guy is height. Okay? How do I know that? I read it in here, right? It's saying that where t represents time since it was thrown, and then it mentions maximum height. It even says the position, to be clear, the position ft or y in meters. So that's telling you that this guy is related to height. So y is dealing with height, and then the x-axis in this guy again is going to be time. If you have some lunatic throwing a rock from a seaside cliff, and I say lunatic, that what I mean is anybody. Let's be honest. There's nothing more fun. So I'm throwing this stone, okay, and I'm wondering when it will hit the water. So we can basically assume that the water is going to be our x-axis, okay? So after how many seconds after reaching its maximum height will the stone hit the water? So again, they've added a little wrinkle in there. They've given you a rule, they've given you a scenario, and the way this is phrased is what's going to trip people up. What are the things you have to solve for using this guy here now? H and K. So yeah, okay. You're going to have to find, I heard zeros, yeah. So I'll have to find a 0 when it actually hits. And what did you say?
H and K.
H and K. Now I again, they mention maximum height. I don't need the K. I just need to know when it reaches K. So I just need to find this guy here, and then I can find the distance between those two things there. That's the hard part of these guys here. I'll leave the rest of them for you to kind of decode on your own. Some of them are kind of similar, as you can see here. Like there's some similarities to them. This one is very similar to one of the ones you did on a test as well. And it's the last one I'll try and like prep with you really quickly. So just, you don't have to do too much with it right now. They're giving you a rule right there. What form is that guy in? Just take a look at it. Rule H is equal to
Standard.
Yeah, vertex, standard, perfect, vertex. So that's going to change where I look on my memory aid. That's going to change how I find H. That's going to change how I find K. And then the framework of this question is saying that both fireworks follow that same path. Again, kind of an impossibility, but let's just pretend that this is reality. Okay, I shoot it off. Firework A explodes here, and firework B explodes 1 second later. So again, thinking about the fact that I already have the rule, I'm looking through my list of the things that I can solve for. if I know the height of when it explodes for A, what is it I would be looking for first? Well, I have a y, so I'm looking for the yeah. I have the y, so I'm looking for the x. Okay, and that's basically it. You're just gonna walk through this stuff now and go like, what was I given? What can I solve with what I was given? Well, if they gave me a y, I'll be able to find an x for it. And then once I find that x, I'll be able to add 1 to it, meaning I'll have a value for x. So let's say x plus 1. And then last but not least, we would be solving for a y given an x. So that's the premise of these guys. You're having to decode from the phrasing, which of those things am I solving for? That list on the backboard there. So get to it.